Please remember to share, like, and subscribe for more videos like these. It would mean a lot to the growth of the channel. Also, join the community subreddit, Creation and the Universe. Do you remember in school when all they told you about Egypt was about the mummies and tombs and not about the advanced skills and intricate knowledge they possessed? A rule of thumb these days is that if you are an academic archaeologist or geologist, then you most definitely must be smart, and you most definitely must be right about all things related to ancient Egypt and working in the best interests of humanity. But what all the most powerful global financial institutions, authoritative figures, and governments have continually shown us is that the people in power only look out for their own best interests and own legacies. That said, most people only speculate about and reaffirm all the false doctrines that were spoon-fed to them. They do not actually understand chemistry and stone structures, and they definitely do not understand fundamentally how the planet or nature works. Nonetheless, let us move on to the truly magnificent realm of Egypt and see for ourselves its true wonders, but not to the Great Pyramids, the Sphinx, or mummies, as they already get all the attention from government officials and tourists. Instead, we are going to take a look at the coarse grain rose granite blocks of the Osirian temple and the strange patterns found on the unfinished granite obelisk in the Aswan quarry. The Osirian boast a wall where the adjoining blocks that constitute its upper section clear signs or hallmarks of being machine cut, where these marks have the appearance of being related to some sort of roller grinder or rotary cutter of some kind, used to grind down several inches of the outer layers of the block surface. Only the uppermost section of the wall was done this way, as the process seems to have been stopped midway through, so that many professionals and reputable archaeologists and geologists want to insist that the blocks of the Osirian must be sandstone or fabricated geopolymers poured and set via molds and cannot be real granite. However, in actuality, the quarry that all the granite came from has already been found, tested, and matched. Plus, in yet another pushback, many standard Egyptologists and reputable institutions insist that the marks on the wall must have been done with dolerite pounder stones, or that the blocks were preheated with fire and then immediately chiseled with copper or bronze, which cleaved the layers away. Instead, those patterns only point to machining done by a rolling or rotating tool cutter head or blade that was of a standardized size that moved over the block and removed a consistent level of material every time it made its way down the blocks that were already affixed to each other in the fully assembled wall. Importantly, the clear machining marks visible in the Osirian are not just one-offs, as there are countless blocks, slabs, and rock-cut objects across Egypt that display clear circular saw marks, tube drill holes, and various kinds of patterned grinding abrasions. Moving into the Aswan quarry, which is some 500 miles upriver from the Osirian, we can find more marks that appear all over the sidewalls and across the floor and trenches of the quarry. These marks are clearly not erosion marks, as they match no known erosion patterns, and instead appear very regularly spaced in solid granite bedrock. There are not small chisel marks or irregular handheld pounder marks, as each mark is roughly 24 to 25 inches wide, and the marks collectively form a pattern of grooves that undulate on the surface of the bedrock like waves atop a pond. Hey, by the way, please go ahead and like the video and please subscribe. It will only take a second to click subscribe. Please do this, as we move on to the most interesting parts of the video. So these marks seem to have been produced by a rapidly rotating cutter or grinder attached to some sort of mechanically assembled hydraulic or gear-controlled machine or swinging arm that was strategically positioned so as to allow for it to properly maneuver and cut down into the bedrock with significant ease and precision. This type of mechanical setup might have resembled the steam-powered locomotive or train-pulled excavator, trenching or tractor assemblies used at the turn of the 19th century, which were the main machinery used to build cities such as New York and used in coal mining. As for the grinder wheel or cutting assembly itself, it would have not been a standard or typical metal saw blade, drill bit, or grinder wheel that solely rely on its sharpness, hardness, or abrasive properties to cut into solid rock. Instead, the cutting apparatus used would have likely relied on the more innate chemical and physical properties of the natural rock itself and the geochemical and geophysical processes that created that particular type of stone. In the modern industrialized world, the advanced methods of exploration, expeditions, and surveys that look for crude oil deposits sometimes not only use the physical and visible characteristics of rocks, but also the innate magnetic properties of certain types of rocks as well. Where the observable magnetic effects result primarily from the magnetization induced in susceptible rocks by the Earth's magnetic field, most sedimentary rocks have very low susceptibility and thus are nearly transparent to magnetism. In petroleum exploration, magnetics are used negatively, as the magnetic anomalies indicate the presence of explorable sedimentary rocks. So instead, magnetics are used for mapping features in igneous and metamorphic rocks, possibly faults, dikes, or other features that are associated with mineral concentrations, where all the data collected at the end is usually displayed in the form of a contour map of the magnetic field, and various interpretations are often made of the profiles. Moving away from this impromptu and comprehensive lesson in large-scale oil exploration, let us now look at the covalent bonds, chemical makeup, and magnetic properties of the different mineral components found within most rocks, which would give these rocks their magnetic properties or lack of. All natural rocks, especially the hardest igneous and metamorphic rocks, contain silica quartz crystals woven throughout their structure, where this silica is chemically known as silicon dioxide, which cannot readily expand when exposed to rapidly increased temperatures and pressures. The chemical composition of granite is typically 70 to 77% silica, 11 to 13% aluminum, and 3 to 5% potassium oxide. While corundum happens to be a crystalline form of aluminum oxide and typically contain traces of iron, titanium, vanadium, and chromium. Generally, the magnetic susceptibility of a given rock type would be related to its content of metallic elements. Unfortunately, when most people hear of magnetic properties, they only understand magnetic attraction, but beyond ferromagnetic properties, there is also diamagnetic and paramagnetic properties, which in accordance with Lenz's laws manifest within various metallic elements or their oxides and sulfides whenever they are near electromagnets or changing magnetic fields. For example, pyrite is still very responsive and susceptible to permanence and magnetism, even though pyrite, which more commonly is known as fool's gold, is an iron sulfide mineral and not pure iron. These properties of natural stones and minerals are what facilitate the existence and efficiency of modern induction furnaces, which uses alternating electric current at ultra-high frequencies to induce heat into metals and crushed mineral ores to cast and smelt all the metals currently used across modern society. This was exclusively explained and demonstrated by Buffalo University in 2016 when they tested an ITC induction furnace to melt several rock types. As such, Given that both chemistry and alchemy originated from the land of Kemet, it is likely that the Egyptians may have understood the fundamental or innate chemical, metallic, and magnetic properties of very hard rocks, and as such designed, built, and utilized tools and techniques that harnessed those properties and had it all working in their favor. Therefore, looking at the amazing works of the ancient Egyptians in this new context, instead of only seeing them using dolerite pounders wrapped in ropes and sticks, the creators of the pyramids may have been using rotary cutters that utilized high-frequency magnetic induction, which helped to maximize the abrasive cutting feed rate into natural stones and bedrock. Essentially, these tools would have been designed to cut using a duality of processes, using changing magnetic polarity, which would induce heat directly into the surface being cut, which on a microscopic level would make that rock surface easier to cut or grind down. This is because the heat introduced through magnetic induction would simultaneously heat or even melt the metallic mineral components in the stone and fracture or shatter and loosen some of the silica glass that held these components, all done on the microscopic scale within the rock. So, the outer surface of these rocks that was exposed to these types of tools would not have had the appearance of being burnt, but they would have a brittle and petrified feel, almost like you could use your fingernail to scrape away granite. Even though granite is 7 on the Mohs hardness scale and a person's fingernail is only 1, which is the lowest. To end this amazing video, it should be noted that all these types of ideas will be labeled as debunked ideas, as no such magnetic tools were ever found in the archaeological records of Egypt, and the standard model suggests that the pyramid builders' slaves only had access to stone hammers and copper chisels smashing together. Nonetheless, the stone marks tell a different story. Remember to get our book on Amazon. Links in the description. This was a Creation and the Universe production, the channel that takes journeys into the unknown, exploring creation and the universe. Please remember to follow, share, like, and subscribe.